Learning target 2.9. I can describe the properties of ionic, covalent, and metallic bonds. Okay. Ionic compounds, or bonds, same thing. This is going to be between a metal and a non-metal. And as a reminder, how can I tell the difference between something that's a metal and a non-metal? I can just look at my periodic table. Good buddy. Okay. Your electrons are lost or gained. You can think of them as stolen or given away. Let's look at covalent. That's a nonmetal and another nonmetal. Electrons are shared. Okay. And metallic, it's what we call a mobile movement of a sea of electrons. Okay. And electrons are also shared. Okay. In terms of their melting and boiling points, okay, this is a high melting point. This is going to have a high boiling point. Why? You have to break each bond. So you can imagine this as a piece of Lego. Ever play with Legos? Right? You have to stack each one on top of each other, but I'm not very good with drawing 3D figures. Right? But you have to break each bond. So it's going to have a high melting point, high boiling point, because it takes a lot of energy to break each bond. Okay. Now, covalent compounds are going to have low melting points and low boiling points. Right? Because you're not needing to break each bond. Not breaking each bond. Think of this as a ball pit. I'm going to have a ball pit here. Bloop, 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 bloop. So have you guys ever gone to like McDonald's or something and you go and you jump into this ball pit? Whee. Okay, so you jump into the ball pit. Does it hurt? No, right? Because if you imagine a covalent bond, it's two nonmetals. The electrons are kind of shared. You're not actually breaking each bond. They just sort of move out of the way for you. So that's nice. Okay. Metallic, two metals, also high boiling point and high melting point. Okay. In terms of what they feel like, ionic ones are hard and brittle. Remember, think of my Legos. Nobody wants to step on a Lego because it hurts. Right? Hard / brittle. Covalent is soft and squishy. And yes, squishy is the technical term of this. I'm just kidding, it's not. But it's soft, right? It's softer because it's non-metals. Imagine, again, your ball pit. Right? It's not too hard. Okay. And finally, metallic, obviously it's a metal, so it's pretty hard as well. Okay. Let's take a look at flammability. Flammable? Not really. That means, can you light this on fire? Think about it. Metals, they conduct heat, right? They're not really flammable. Okay. Whereas covalent compounds are more flammable. Why are they more flammable? They contain C's and H's, carbons and hydrogens. These are very highly flammable. They're also nonmetals. Okay. And these guys, very similar to ionic, not really flammable. Okay. Ionic compounds they enjoy conducting electricity when dissolved in water. Oops. Now the reason is they have these electrons, right? The electrons can go freely between them, right? when they're dissolved in water, that also means that they're soluble in water. Whereas covalent compounds, they don't really conduct electricity well. They are also not very soluble in water, right? If you recall, water is what we call polar. Water is polar. And most covalent compounds are actually non-polar. That's just good to know. Non-polar. Ionic polar. And that's because there's a plus and a minus side, right? One side likes to pull electrons away. Covalent, they're all shared. No one's really going to pull more. Okay. Water is polar. Covalent compounds will tend not to want to dissolve in water very easily. Okay. A couple other things about metallic. Well, they're hard, right? They're ductile. They're shiny because they're metals. They're also very malleable, meaning they can be bent really easily. Okay, so given all of these properties, that's a lot to remember. I would highly recommend my Lego and ball pit comparison, right? But really what you're going to see is a question that looks like this. Which of the following substances would primarily involve a transfer of electrons? Well, the ones that transfer electrons are going to be ionic, right? They're giving and taking. Which one of these is ionic? Let me think back to my notes. The ionic ones are going to be a metal and a non-metal. So, LiCl. If I look on the periodic table, Li is on the left, chlorine is on the right.